All right, so from your sleeve of notes, you should have a pink page that looks like this. Gonna grab that. It's gonna go on page 79.
No.
Yes.
No, not that.
All right, so we're gonna graph the equation y equals x cubed. Okay, so just like we did on the square root page, we're going to plug in some x values, -2, -1, 0, 1, and 2. What does it mean to raise something to the third power? Multiply it by itself 3 times. So what is -2 cubed?
Nothing.
-8?
Yes.
Oh, never mind.
Good job, Mary Kay.
Wow.
Okay, what is -1 cubed? -1. What is 0 cubed? What is 1 cubed? What is 2 cubed? 8.
Wow, amazing.
Okay, let's plot those points. See what kind of strange graph we get. I know it's really small graphs, I'm sorry.
Yeah, the graphs from the average 12.
No, they're just printed really small is what I meant.
Bro, how you build like that? It's built like one of those, like, you know, the things you used to look at?
Polynomials?
Yeah.
I'm gonna lie, I made it forever. I did it forever because I assumed that was gonna be it. This is what happens.
Gotcha.
Caught me there.
You win some, you lose some. Okay, so let's talk domain and range. What kind of numbers can I raise to the third power?
A lot.
A lot. All of them, right? You can raise any number that you want to the third power. So my domain is -infinity to +infinity.
Thank God.
Okay, what about the cube, or not the cube? What about the range? Y values. It's the same because these arrows go on forever in both directions. So the range is -infinity to +infinity. Okay, how do you undo a cubed? You do a square root, but with a 3, so it's a cubed root. So now we have y equals the cubed root of x. Like the other day, the square root undid the squared. A cubed root undoes the cubed. Need you to roll your eyes a little bit harder at me. Okay, so this time I'm looking for numbers that are easy to take the cubed root of. What? That would be a square root.
Oh, I thought you said no. I was like, what you said?
Probably going to be these numbers right here, right? Because what's the cubed root of -8? What's the cubed root of -1? Okay, so what's going to happen to my columns here? They're going to switch. Swap.
Wait, what?
This is the table you're going to want to write down. Jonathan, write this down. All right, now plot these points. It's not going to look like a parabola, Mary Kay.
Is it gonna look like the dancing man, but like backwards?
The dancing man.
There's like 2 arms.
Oh, do you mean like those things that are outside of car washes?
Yeah, sure. Oh, yeah, I think it's If you go like this.
Look at the thing on the image there. Like a cactus.
Only one series with that for days.
Oh, no.
I did this one. I didn't do that one.
Okay, so what's my domain here? My x values. Negative infinity to positive infinity, because those arrows go on in both directions forever. What about the range? Same thing. All right, so grab a sheet of graph paper. This is going to go on page 80.
I think there's some extra graph paper up there.
Oh, really?
I used to take the graph paper.
Yeah, one time I tried overdraft.
Yeah.
Oh, yeah. My teacher was. I kept thinking about that you had one posted, so I could just print out myself.
Yeah.
Yeah, that's what.
Somebody asked me to post that, and I was like, it's not a bad idea.
You know, I think I already have like 30 for that question to work on.
The amount of graph paper that I own because of my sewer is.
It's phenomenal.
You're welcome. You are welcome. Just giving you a minute to get caught up. All right. So what are my transformations this time?
3, and plus 4.
The 3 and the 4. Do some
Vertical,
No.
vertical stretch by 3 and left 4. So left 4, vertical stretch by 3. And I would like you to notice my newest additions to our room. Me explaining to you that left is that way and right is this way.
I was in here, I was appreciating that.
Because yesterday I had at least 5 people in every class go the wrong direction. Okay? So,
Just directionally challenged.
Or now to a
I need this number.
you know, I was trying not to do it.
Horrible.
Okay, so our parent function,
That thing is, I still choose this for left, even when I do this.
okay, our parent function had this table of values.
Oh my god.
Okay, this is what we just wrote on the other page, right? So just like when we did moving the monster, you take your original set of points and then you transform them based on the transformations, okay? So we're going to take the point -8, -2. We're going to take that point, we're going to go left 4 and stretch it vertically by 3. So if I went down 2, I need to go down 2 more and 2 again. That gives me the point -12, -6. -1, -1, go left 4, and a vertical stretch by 3. So if you went down 1, then you need to go down total of 3. Which is the point point -5, -3. Point 0, 0, move it left 4. Since it's on the x-axis, the vertical stretch is not going to change it. That's the point -4, 0. The point 1, 1, go left 4. Vertical stretch by 3. It's -3, 3. Point 82, go to the left 4, vertical stretch by 3. So you went up 2, 2 times 3 is 6. So that's going to be the point 4, 6. You do not have to write the coordinates of the points. I put those on there so that those of you who don't graph quite as quickly as I do can figure out where that point is without trying to count from so far away. I try. Okay, what's going to be my domain and range? All real numbers, -infinity to positive infinity. What's really nice about cubed roots is it's always going to be that.
You should have told us this before like the last one.
Before the other one. You'll survive without knowing that. Before now.
But then grades survive.
Okay, here's another one.
Let's do this.
Nope, I'm going to make you do it without me.
What?
What?
Don't do that.
All right, so try that one.
Okay, I think I did it. I got one of these sides.
Why are they bunnies? Why not just bears?
But there's a bear one?
Gummy bears? Throw one at me.
Wait, is this a guy button?
They are bunnies.
Okay, does anybody need me to write in the ordered pairs? Or are you okay?
Yes, I need you to write me the order of the
Seriously or no?
Yes.
Okay.
I think I should. I bought it 10 guys.
Oh wow, most places have to. Oh, you fixed it.
Okay, that was faster than I thought.
There you go. Do you feel the need to do one more, or are you okay on graphing these?
I think we need a graph.
I'm not taking your word for it.
Like, okay, I always get confused.
You
I
can
know there's an order for the transformation you go in.
Yep.
But how do you determine the order?
So it's like how you work your way from the inside out. So like on this one, the first thing you would do to x is add 4. So that's why it's left 4 first. And then you would multiply by 3. So that's why the vertical stretch comes after that. So it's you start with the x and work your way out. So like right here, the first thing you would do would be multiply by -1 and then subtract 1.
First you look inside, but they're both outside.
Right.
First you look inside.
But you would multiply before you add or subtract.
Oh,
Right?
yeah.
Okay.
I don't need 10 dollars. They're lagging.
It's kind of important. Okay. So to remind you how to fold these, take the bottom of your graph paper and fold it up. So cover up that question 2.
I never do this right. I just no, figure that out.
Okay, then you turn it over
Oh my gosh, this is perfect.
and fold it up to the top.
I did a perfect
I'm
two.
just gonna hold it like an accordion.
Yes, that's what I did.
I folded it perfectly.
And that's gonna go in on page 80, and then you're gonna get the last, I'm not gonna say the last book, but the next book from your sleeve, the Solving Radical Equations.
What is that? I'm gonna write a whole essay. No. Okay.
All right, so this booklet's gonna go on page 81.
What?
To solve a radical equation, the first step we're gonna do is isolate the radical.
I'm writing in red so that it's
I think I see one,
punching.
because I'm angry.
Hey, green, red, blue. I do have, I'll have that.
Then you're gonna raise both sides
She really scribbled out the line.
of equation to the same power.
What's this red tiny?
I know, the first one was like super big and now it's tiny.
And you're gonna solve the polynomial equation.
Okay, what can you do?
And then check for extraneous solutions.
Tiny.
Yep,
Wow, that's a good topic.
it is a new word.
Like extraterrestrial?
Yes. Basically, it just means check your answer to see if it actually works.
Why did you do that?
Too much work.
Because the mathematically correct way to say that is extraneous solutions.
Oh, I wrote equation. I meant to say solution.
It's all hoops.
Yep.
It's all hoops.
Okay, so part A, I have to isolate the radical. So what do I have to move to get that radical by itself?
Times 4.
Oh my god, I almost did it.
Okay, I'm trying to get this right here by itself. Somebody said it. Is that you, Caden? What'd you say? It was right. I need to divide by 2. I need to get rid of this 2 over here. When you divide by 2, you divide both sides by 2, yes. So I have the cubed root of x minus 3 equals 4 divided by 2 is 2.
Oh, I like these.
They're not graphs. All right, how do I undo a cubed root?
Cube it.
Cube it. You raise it to the third power, right? To undo a root, you raise it to a third power. So you raise both sides of the equation to the same power. So your cubed and your cubed root undo each other. So x minus 3 equals 8. Thank you for not saying 6.
Oh.
Is x by itself? No, how do I get x by itself? Add 3.
Took me like 10 minutes to figure out what 8 plus 3 is.
That was a really fast 10
Oh
minutes.
my god, I got that wrong.
So I love these things. Is this it? Because it's so satisfying. That's how we have to
Okay,
grab it.
I really hate when you ask me, is this it? Because then it makes me seem like a bad guy. Okay, but what was my last step? Check your answer, okay? Use your calculator to help you. So I'm going to have 2 times. Okay, let's talk about a cubed root, because you don't see one on there anywhere, do you? Okay, you hit the math button underneath the alpha button. Math underneath alpha, right here. Do you see a cubed root on there somewhere?
Yeah.
Option 4.
Option 4. Wait, what if you wanted to do more than 3?
Let me give you an answer.
Okay.
Okay, my solution was 11, so I'm plugging in 11 for x minus 3. And when I hit enter, do I get 4? Yes, so I have checked my answer and I'm good. Okay, so let me talk you through it again. So 2 times math, option 4 is a cubed root. 2 times math, option 4 is the cubed root. I plugged in 11 for x because that was my solution. Minus 3. Make sure you use the minus and not the negative. And hit enter.
Amazing.
You're such a
Okay, let's look at the next one. So I checked it and we're good. I'll show you what's going to happen on part C, but for right here, we're going to do this one. All right? So what do I do?
Should we write it into?
Bring it up.
Yep. Raise it to the 5th power on both sides of the equation because my radicals are already by themselves. So the 5th and the 5th root cancel out on both sides. You get x plus 4 equals 3x minus 2. And then hopefully you can solve this equation.
I don't think I can.
We're going to subtract x from both sides and add 2 to both sides. Six equals 2x. Divide by 2, and what does x equal? All right. So we're going to use the calculator to help us check our answer. What kind of root do I need this time? A 5th root. Do you see that on here anywhere?
Yeah. X's. Right there.
2 times math.
2 times math. No, just hit the math one. Okay, you don't see that anywhere. Okay, but there's this number 5 where you have an x root.
I said that.
Okay, well, if you select that, it says answer. Okay, so what that means is you have to type in the 5 first. So type in the 5 first. Math, option 5. 3 plus 4.
So did we not do it?
Well, this would have to equal this one, right? So I need to plug in 3 times 3 minus 2 and do the 5th root of that and see if it's the same thing. Okay, if you hit second enter, it just retypes what you had the first time. So we can change this. Are they equal? Probably. They look the same. So my answer works. Yes.
I've taken a Microsoft Excel course.
Have I? Yes, I've taken Microsoft Excel like 14
I can
times.
tell.
Are we on the calculator?
There's stuff plastered down all of your like resumes, right?
What?
Anyways.
Anyways, my answer worked. All right, now let's look at part C.
What is that?
Do I have a radical by itself?
Yeah.
Is this radical by itself? Is there anything multiplied or added or subtracted or anything? It's all by itself, right? So how do I undo a radical? This radical, I should say. I'm going to square both sides. But I have to square the entire left side.
Where are we squaring it?
To undo this radical. So this side becomes 7x plus 15. The left side does not become x squared plus 1.
Wait, what?
Really? Because you have to do this times itself. X plus 1, x plus 1.
Well, that's where you got me, sorry.
Which means you have to distribute. So we get x squared plus x plus 1 equals 7x plus 15. So x squared plus 2x plus 1 equals 7x plus 15. What's going to be my next step? That's a good question.
Do the rest.
Which is what?
Finish it.
How?
You did a funny, like, transfer.
Minus 1.
Okay, I'm going to set it equal to 0.
Oh.
So I'm going to subtract the 7x and the 15. Okay, we're not going to do example D. So if you need that space over there, you can use it. So this is going to give me x squared minus 5x minus 14 equals 0.
AC method, guys.
Do you have to do the AC method?
No, you just do the next one.
Just the x method. What are factors of negative 14 that add to give you negative 5? Positive 2 and negative 7? No.
No, the second method was weird.
So you get x plus 2 times x minus 7. He's right.
No.
He's right.
Okay, so I still don't have x by itself. X plus 2 equals 0. X minus 7 equals 0. So x equals negative 2. And x equals 7. But I have to check my answers. Yes. No.
Oh, sorry, you did.
Okay.
Is there anything else?
So the first one I'm going to check is negative 2. So negative 2 plus 1 is negative 1, right? So I need to plug in negative 2 over here. The square root, 7 times negative 2 plus 15.
And no, I
That's not the same thing, is it?
know.
No. Which means negative 2 is actually a fake answer. It doesn't actually work.
What does that mean?
It's an extraneous solution.
Wait, somebody said that was an imposter.
It's the imposter. Yes.
Wait, why?
Because when you plug in negative 2 to check your answer, the left side was negative 1, the right side was positive 1.
Okay, but like, can you give us a mathematical explanation?
Yes, because when you square both sides over here, you can have a negative 1 squared to get a positive 1, or a positive 1 squared to get a positive 1. But when you take the square root, you only get the positive answer.
I get it.
Okay. All right, so 2 or negative 2 did not work. It was extraneous. Now we have to check 7. Okay, but remember, if you do second enter, it retypes it for you.
It's right there. What am I gonna do with my head?
Yeah.
7 does work. So do you see why I make you check your answers? Please say yes.
No, there's a possibility.
Okay.
It's still in choose the negative, and that's how we do it.
All right, on the next page, I want you to do E and F without me.
I got all this over.
Work problems E and F, both of them. 2 problems. You ready to check them?
Yes.
Did you check with your neighbor?
Yes.
Okay, I was really
Oh,
wrong. Okay,
No,
I was right. What? I changed it, so that I was wrong, I was right. Oh.
Which one, Emily?
I'm trying to figure out how I messed up the sign in F. Because I got the 30 and the X and the X squared, but I messed up the sign.
So when you move this X over, you add X,
Yeah, I think I
subtract 30.
was looking in like a different order, so I didn't do the sign correctly.
Hmm.
I told you,
Because I moved the square over and like, and then,
But you're good now?
yeah.
Okay.
I told you it's always negative.
All right, we're going to look at part G together.
Yeah.
All right, part G. Why is this one weird? Because there's a 5 in front. Can I get rid of that 5?
Yes. I feel, oh, divide. Wait, no, but that'd be weird.
If I divide by 5, won't it just end up on the other side in front of this radical? Okay. So what I'm going to do is I'm just going to go ahead and square both sides. But remember that you're squaring the whole thing.
Wait.
So on the left side, the square root and the squared undo each other. 35x equals. On the right-hand side, I have 2 things being multiplied together. So I have to distribute the squared to both. So I have 5 squared times the square root of x plus 2 squared is just x plus 2. It is gross. Okay? But what is 5 squared?
25.
25. What do you do when you have a number in front of parentheses like that?
I don't know.
Distribution. So 35x equals 25x plus 50. Now what? Subtract 25x from both sides. $10x equals 50. So what does x equal? Okay, so plug that in and check to make sure that it works.
Imagine if only answer being extraneous.
Oh, what now?
Really not good. You're really cool.
when I plugged it in, I got the same thing both times, or on both sides, I should say. So it worked.
You're not efficient all
Okay? We're gonna skip H and skip I, but I want you to work problem J without me. Thank you. I believe in you.
Alright.
Like when they don't have like, they just like, they just like writing like, that's easy.
Oh, I did it wrong. I mean, if you get stuck doing one thing, you do the other.
You still haven't sent like doing that 5 times.
Yes, sir.
I did it. I did it for you.
I did not do, I got that.
Yeah, I'm not.
Like, that's just needed.
Did you forget to cube the 2?
No, I did. I did. Yeah.
Okay. Just checking. Okay. Now we're gonna flip through. We're not gonna flip through, I lied. We're gonna go to the next page. All right. Rewrite x to the 1/3 as a radical.
Yes, your brain is connected, your eyes are connected to your brain.
No, they're not.
Okay, how do I rewrite that as a radical?
It's a radical.
It's like square root thing.
It's like the square rooty thing. Where does the 3 go? It's your index. It goes right there. Where does the x go? Underneath. Where does the 1 go? It can go either on the inside there or it can go on the outside. It's a 1, so it doesn't matter. But if it were a 2,
Oh, I just blanked out completely. I know what this is. Sorry. I'm not.
it would make a difference. Hey, remember that a rational exponent or a fraction exponent can always be written as a radical expression.
I'm sniffing
On your right side.
it. Part.
Right here. Right here.
Okay, so on part A here, I need to get my variable by itself so that I can deal with that fraction exponent. So how do I get rid of that 4?
Divide.
Divide both sides by 4. X to the 2/3 equals, what is 36 divided by 4?
9.
9.
Nobody, she's testing how quick her brains are.
I did
Okay, we just did this up there, so I'm going to rewrite this as the cubed root of x squared.
Now we do the funny 3.
Okay, now you have the cubed root of something equals a number. So how do you undo a cubed root? You cube it. So raise it to the 3rd power. X squared equals 9 to the third power.
Oh, what is that?
You have a calculator.
That made me really uncomfortable.
81 times 9.
20-something.
Oh my god.
I knew I was.
That's what I was gonna say.
729.
I knew her.
Okay, but I don't have X by itself yet. Square root.
Well, I would do the plus or minus.
I swear if there's an I in Stuart, I swear, it's just 27. It's Stuart.
It's a positive.
Oh, wow, she did it for us.
Thank you. Had mercy.
So X could equal 27 or negative 27,
Oh, it's the I.
but you have to plug them in and check.
Oh, no.
Oh, no.
Are you gonna count points off if you just leave it as plus or minus 27?
No, but whenever you check it, one of them may work and the other one may not. Okay, so I have 4 times 27 raised to the 2/3 power, which does give me 36, not 26. So positive 27 works.
Right. Negative 27.
Negative 27 also works.
What, how'd you do that? Miss Stewart?
I didn't have to. It's good.
How did I do what? How did I do what?
You push the number forward so the negative doesn't separate.
Yes, so if you look right here on the delete button, above it in blue is INS, that means insert. So you can insert a negative right there.
Wait, is it like second insert and then the one you want? Or is it
Second delete and then what you put in. Yep.
Oh my god.
This is witchcraft.
Have you taken a calculator course?
No, I've just learned some tips and tricks along the way.
10 tips and tricks.
Okay, try part B.
Wait, whoa. Slow down.
Wait, no.
Yes. Okay, get this by itself. That whole expression right here, x plus 2 to the 3/4. Then rewrite it as a radical. But you have a calculator.
How'd you do that?
Magic.
You probably would.
I told you, she's a witch.
No, I know you said it.
Can't share my secrets. No, I raised both sides to the 4th power to get rid of the radical.
Okay, but where did that three come in? The 3/4.
It's the top of my fraction.
Right. And that's the bottom.
So now it's hanging out. Now I need to undo a cubed.
So you cube it.
Cubed root it.
No, that kind of confused my head.
Wait, what? That's not what I was gonna do. Wait, why did it do that? No.
Math is dumb.
Brian, what? I did.
Oh, okay.
How did you do that? How?
Okay. So right here, I rewrote it as a radical, and it was a 4th root. So So I got rid of the root first and raised both sides to the fourth power.
Why didn't you just do the X plus 2 instead of?
Why didn't I multiply it all out?
Yeah.
Because here I can cubed root it, and then I don't have to try to solve a polynomial.
Maybe like, I guess you have to do that, so I have to tell you like third every day.
All right, so I have 14 plus 2 raised to the 3/4 power minus 1, and it does equal 7. What?
Oh, okay.
Which is what the right side equals on my original problem. Okay. I feel like we need to do another one of those because that blew your mind a little bit.
Like Paula Brianna. Are you still recording?
Yes. All right, so on the next page, example F. On the next page, example F. 26 equals -1 plus 27x raised to the 3/4 power.
Okay, you know how it's geometry, like shapes and stuff.
Mhm.
So what is algebra? This is what numbers, but numbers are important.
It's graphs and graphs.
Is that what it is?
Is everything in algebra graphable?
No.
Then like what would you say the main component of algebra is besides numbers?
X.
Back to the.
Equations.
Wow.
What is the main numbers? Not geometry.
It's variables and numbers.
Okay. Whatever.
All right, try part F, or do you want me to do it with you?
We have to do it.
Okay.
Yeah.
What's the first thing I'm going to do? Add 1. Okay, my term with the fraction exponent is by itself. So I'm going to rewrite this as a radical. So the 4th root of 27x to the 3rd power. Okay, you have a calculator.
I don't know where mine
Are we gonna have to 27 to the 4th power?
Yes.
Yep, it
That's
is.
more.
531,441.
No.
Yes.
You know it's any
P.
numbers.
It's too many numbers.
I'll even make a skeleton.
What's that kid?
I don't know how to read that number.
531,441.
I'm gonna take a guess and say,
I think it's 7.
I think it's like a 17.
I think it's 30.
I love that y'all are guessing, but you have a calculator.
Placing bets will help you.
19? 23.
I did.
Maybe 1.
Thank you.
That's lame.
I was close, I got 82.
I think they're the one.
Yay.
Divide by 27,
And then the answer is x equals 3.
x equals 3.
Well, you gotta check it.
Yes.
Check it.
Wow.
So -1 plus 27 times 3 raised to the 3/4 power. Did it work? Okay, one last one. Do part G without me. It's easier.
Well, that's easy for you to say. I got it. You could give.
Well, you think I know? Did I do the first? Did I do the first line? Ooh, I put it in parentheses.
That's fine. Parentheses are fine.
I just bring it in. That's what the actors were.
Wait, how can you bring something by one?
You don't. Anything to the first power is just itself.
The word, what's the word place?
I did. I don't forget everything. Just most of it.
Well, you said flying span.
Okay. Let me really look back.
Okay, does -4 equal +4?
Yes.
Yeah.
Maybe it's like that.
Okay. That's it.